Welcome to the ninth session of the OpenMusic Study Group. So this is going to be uh, just things that we've been working on in 2020, uh, very loosely. James, have you got? I think I've enabled screen sharing. So if you've got,
Sure. Yeah, I'll just speak a little bit. I'm James in Montreal. I'm a very new user of Open Music because I've been working with it to figure out some feedback loop between um, listening and playing and composing things. And my hope is that as I develop those tools, it will allow me to um, build etudes, sort of build take my analytic, like starting from a place of analyzing existing music to then abstract those things and develop them into compositional exercises. So I'm going to share my screen now to give you an example of what I mean, what I've been doing. So I have two patches here. One of them, very quickly, just based on my interest, I really gravitated towards Pulse Maker as a way of generating different kind of rhythmic subdivisions and things. And so this patch is called scelsi, and it derived from I'm learning the scelsi three etudes for viola, and so basically all I'm doing I have uh, I'm creating three eight bars, and I've got a rhythm tree with different kinds of subdivisions of that. Um, so all kind of manner of um, groupings and syncopations within that. And it's basically a kind of trill etude. So one of my first challenges with Open Music was to figure out how do I create a looping pitch set that will like I specify sort of groups of pulses, and I want to just be able to arbitrarily repeat um, any some kind of pitch material over that. So I have this subpatch here, which is, I think this is very much copied straight from the docs here. So I'm using a loop list and a repeat n to basically just do a trill over these two pitches. So I mean, it's very simple stuff that I'm doing, but it allows me to kind of generate this kind of thing. So this is just the example patch. I have a few variations of this patch that use more elaborate pitch material, use more elaborate rhythmic subdivisions with different kind of meter groupings and stuff like that. But this is just to kind of demonstrate and show an example of what I'm doing.
could I ask a quick question?
Absolutely.
Certainly, because this is kind of OM sharp, and the sort of the loops, using the loops in OM sharp slightly different to sort of the way loops are implemented in OM. Do you mind just sort of explaining kind of what's happening um, in your loops patch, kind of
Okay.
just to kind of make it clear
Sure.
the
Actually,
differences maybe between OM sharp and OM and kind of what's happening there.
this will be an interesting discussion because yeah, I'm going to talk a little bit about. I started off learning OM6, and I have to be completely honest that I found the user interface absolutely unbearable to use. And so when I discovered OM Sharp, I was just thrilled because for example, things like patch connections will just easily snap to. So I don't know if I can really speak to the difference in the implementation of the loops. Um, Basically what this patch is doing, the pulse maker, you give it a list of metric numerators and denominators. So this will create 3/8 measures. But if I were to do something like this, it would give me a 3/8, a 4/8, a 5/8 measure. Or alternatively, I could probably do something like this. I'm sorry if you hear that. There's in Montreal right now, we had an enormous snowfall last night, and what you're hearing is the snow removal truck. So here you see I have 3/8, 4/16, 4/5/4, and that will correspond to the lists that I gave the first two, the measures argument and the beat unit. And then the pulses, these are the the groupings, the pulse groupings. And these are going to a voice object. So this pulse maker object will create a rhythm tree. And then what I have to do, if I don't have this loop patch, what'll happen is it'll just default to one note. So I can give it a list of pitches. For example, like this. And what that'll do, so I don't know how many pulses are 1, 3, 9. So there's 10 pitches here, right? So like basically this is my pitch material, and I have 10 pulse, 10 or 11, 12 pulse events. So I need to somehow loop over these to avoid having it, like, because otherwise I would have to do something like this just to get a trill. So what's going on in this subpatch is maybe it would be cool to do something like this. Trying to get a Lisp and an evaluation window. Here we go. So what happens when I evaluate this? So this will just, this is an arbitrary limit. I just said 100 events. So if I were really clever, what I would do is somehow calculate, you know, in my main patch, I would somehow do a count of the number of pulse events. There's different ways to do that, and I would probably provide that as an input to the loop patch. But for my purposes, I just said, just repeat this 100 times. I don't really care. So that's what the repeat n is doing. And then I sort of flatten that out to a list. What was a little bit confusing for me, like, was understanding the program flow in this sub patch. So basically, when you use an iterator, something like this loop list, you have to yield. So this is a kind of looping function, and then you need to yield it, like yield all the values, which uses this collect object here. And you have to give it this instruction to iterate. So it's a little like hard to follow in a way, because like visually, like I'm not. It's a little bit asynchronous with what's going on here. It's this is I'm not really the best person to explain exactly everything that's going on, but I will show you that I think
Yeah, because I saw
This
with your
is the
repeat
document.
n, you know, you were getting all, you've got your list. So, you know, if you just take that, what's coming out of your repeat n, and then put that into the flat function, would
Right.
that not give you a similar kind of output?
Would it? I wonder.
Possibly, because I'm wondering, because if the voice object just takes a list of whatever you're putting in, it's
Oh,
oh, to connect, you need to connect. Yeah.
okay. Interesting.
Yeah, 'cause
So I don't even need this loop list.
no, I don't think you do. I think you could even, is there n, uh, is it n pulses? Is that function in OM sharp?
With the hyphen or
N dash pulse, yeah, because that you could plug that straight into your um, what do you into your repeat n. That gets your pulses from there.
rather than using this.
Rather than using 100, you could just get that straight in.
So could I do something like this?
Yeah.
So now I have an input here. And where do I get the pulses from?
Yeah, pulse maker. I think straight plug the pulse maker directly in. Try that.
So that works exactly. Wow, okay. Amazing.
So what your n pulse is doing is just taking your input from the pulse maker, and rather than giving you sort of an arbitrary number, it's giving you an exact number of repeats. But I think you might, because there's 2 notes you're repeating each time. So I think you're getting more values than you need.
Yes.
From that.
So that's definitely correct. So that's really helpful, actually. Now I can just kind of do whatever I want here. So that's my first patch. That's really helpful. One thing that I just want to point out here for the viewing audience, because we're just on the general subject of what are the differences between OM sharp and OM6. One thing that to note is that the export to music-xml isn't fully functional. So if you're expecting that kind of functionality from OM sharp, then you may find yourself disappointed in that regard. I will show one more patch really quickly. Maybe you will have some helpful hints, Alan, like you had with that one. So I'm going to share my screen again. And as I mentioned, like my point of departure is is existing repertoire, and I'm purposely trying to make my patches really simplistic, just to be able to have things that I can practice and modify for the things that you would learn and kind of use as the basis for an improvisation or a kind of practice session or something like that. So at the moment, the goal isn't really fully developed compositions or anything like that. So the other sort of work and the goal is to sort of create workflows that are useful. So that one use case is being able to understand rhythmic subdivisions. Another use case that I've found is to try and kind of do score reductions and things like that. So this was a kind of an experiment. I did a very sloppy in a sequencer. I kind of recorded myself playing Webern's Das Augenlicht, and with the goal to kind of better understand the pitch materials, to just sort of abstract stuff. So, I mean, it's really bad. If you listen to this, here's me playing the homorythmic choral interludes of Das Augenlicht in a DAW, voice by voice, because I can't read the four staves at one time. And then I'm trying to kind of align it into just so the idea is I just really want to see what the pitch material is here. I don't care about the rhythm. I just want to kind of view like this. That maybe I can manipulate somehow. You know, and actually there's sort of I sort of have the same problem here, Alan, as with the other one. So basically I have my performance, which is a MIDI file. I'm telling it just show me the chords, align them, quantize them to some degree of resolution, and just give me like a kind of unmetered or like a grid view of these chords. And it's outputting it to a voice object. So I think I just did this myself. I just said I just wrote this by hand. Like I have 4 measures of semiquavers, and I think I didn't. I wonder if I can do the same thing with the get n pulses to generate a rhythm tree that's the actual duration of the number of chords from get chords. How did that work in here? Pulses in.
So you want to get, so you want the same rhythm as the sort of the first voice object going into the second voice object? Like those sort of
well, okay. What happens
tuples?
What happens if I let me just make it evident what I'm talking about. What happens if I remove this rhythm tree object? So I have the line chords creating a voice that looks like this, and it's trying to figure out what my sloppy rhythms mean. And basically, I don't, you know, this I'm not playing. This is not the rhythm. I don't care about the rhythm at all. So just show me this in quarter notes. So I have get chords, and I'm giving that as a list of pitches to this second voice object, and it cuts off after 4 quarters because that's the default value of voice. So so this is the default value of the tree input is a single 4/4 measure, and so I want.
So one thing I would do is if you get the length object and see how many chords, because it's obviously it's just you want sort of one. So out of your in the voice object, yeah. If you then if you even put just repeat n and take a quarter, so you get 15. So put the length into the n of the repeat n.
The self or the number?
The number.
Okay.
And then put the literally write a quarter as a fraction. I don't even think you need to put it as a list, but
Like this?
yeah. If don't put it in as a list, put it just as a quarter as by itself, and then just plug that directly into the second input into the voice. And let's see what that does.
Amazing. Cool. And then these don't quite align.
Yeah.
If you really only care about the pitch materials as opposed to any of the rhythmic information at all, I think the get chords function probably returns a chord seek object, which you could just plug into any instance of that.
Okay. So rather than using a voice.
Yeah.
So if I just take this all, let me just get rid of all of this. Wait, no, I need, I think I had an issue when, oops, let me try this. If I just align chords, get chords, what does this give me? No, that's not useful.
So if you evaluate get chords without evaluating the voice object, it will show what kind of okay. So what's the child object that is going into get chords, or get chords is going into, rather, sorry?
This is a chord set.
That's a chord. So that's a bit odd. Oh, so instead of putting it into self, put it into the first inlet, I think.
The MIDI C?
I think so.
Nice. That worked. That's even simpler. Cool. That worked. One thing I just want to notice, I just want to point this out because it's I get from time to time these weird font errors and font size is unbound in object, blah blah blah. So I don't actually know the reason for this, but it's another peculiarity of OM# that
I suspect that's probably, this is just complete speculation, but I think that the version of Lisp works, the CAPI, which is their GUI, the GUI framework, has been updated, and I think probably as OM# has been developed, it was maybe taking reference for some parts of OM6, and there must be, I suspect, some kind of framework incompatibility there. That's just my guess. That don't don't quote me.
Well, I'll post it in the Discord, and if Karim or Jean want to take a look at it, that would be great. Otherwise, it's just another one of the lovely quirks of OM that we all love. So that's it. That's what I'm working on, and that's sort of where I'm at. And I really appreciate the help and the other eyes to simplify it.
That's great. Thanks very much. That was really interesting. Karim, do you want to take us into what we have to look forward to in the next version of?
Yes, yes, of course. Are you hearing me good? Are you hearing?
Very clear.
Okay. Just I wanted just to point out some things, commentary on what James said about first of all music XML. Well, even because the music XML export, I was the one who started to doing it, because before, just historically to know, before we used ETF export, when it was we had only Finale, to use for exportation, and this worked very good, ETF. Well, and then the Finale guys dropped out this, and we decided to try out with music XML. So it worked for a time, but it was a little bit unstable, because the Finale and Sibelius, when Sibelius came around, their parsers were not compatible. So they read the music XML file in different ways. So it was very heavy to manage, And even now you have MuseScore, which is good also. Well, MuseScore XML doesn't, if you write embedded tuplets and you even write it in music XML by hand, well, MuseScore will not read it, because it's the parser, of each one. So I advise everybody to, I hope someday music XML parsers of all Finale, Sibelius, and the latest, not what's his name, the one who Sibelius came out after. I forgot. Person.
Dorico.
Yeah, Dorico. Yeah, Dorico. Also, all decide on one, really, because music XML is rather like a standard, but not. It's not a standard really, because each product uses their own duration, format, etc. Well, I don't use music XML anymore. I use Lilypond, which I like a lot. And if you want, I am doing some advertisement to myself. I've written a export library for OM. Voila. Okay, that's all. And second thing for James also, OM loop, the loop in Lisp, it's a loop macro. So it's a little bit complicated, I know, for everybody to understand, even as a in code, but in code, in common Lisp code. But it's a very powerful tool, a macro, and it's very. I think it's good to learn it as such. Well, the representation, because it's the first time I see the loop in OM sharp, and well, it's rather a little bit slightly different, apparently, of the OM loop, but it behaves the same, and it's similarly awkward in OM Open Music and OM sharp. Because why is this so? Because all macros is neither a function or a method in Lisp. It's a very particular way to define a Lisp expression, a macro. So they have some keywords, especially the OM loop. Have a very particular behavior. The loop, sorry, have particular behavior, and they were translated visually in these environments, OM sharp and OM Open Music, in order to simulate these macros, because we cannot call macros. Let me share my screen. So what I was saying is OMloop. Okay, I'm well. Okay, so this thing is equivalent to this, if I may say so. Ah, sorry. Okay, if I have loop for en 1, 2, 3, 4, okay, collect. This is a very silly thing. Okay, just to show you. Okay, did you seeing the listener? Okay, so this is equivalent to having this 1, 3, 4, 5. So 4 is this. Okay. Okay, sorry, I am doing some basic stuff, but it's in order to understand. So, and the function here, it's what happens here, okay? Okay, pop. And the collection, collect, okay, it's here. Well, the big difference, the main difference in both, I think, OM and OM sharp are the outputs. Finally is the out thing in OM sharp, I've seen, okay? It's the output. And this thing is the awkward thing in both each time. It's you need this visually to launch the iteration. Okay, so if I evaluate this, it's the same. Okay, okay. I will not take too much time, and I will.
That's really interesting. It's really good to see, because I think sometimes it's especially with the kind of the kind of graphic of loops and things, it's hard to sort of marry the two.
Yeah, yes, yes, I know. And in your last video, you showed how OM sharp showed the code, no? When you
Yes.
have a patch. Okay, so this was included in OM. It was a hidden feature, and I managed to put it for you, but it's not that that integral. So this is a new but this was in a last. I wanted to show it last, but if we take, let's say we take this this patch. If we select this, we type J, and we have the expression here. So it's like in OM sharp. It was
That's
already.
brilliant.
So if you want, just we can from OM random, from plus, from list. Okay, but this is a in progress thing, because it doesn't work for lambda functions. It worked, but it's a little bit gibberish, because you have lambda, etc. And doesn't work for the loops, because it's a macro also. So this is in progress.
I'm just aware of kind of our time, so um, I'll share something quickly,
Okay.
just a bit of kind of fun that I was kind of working on. Um, the Recently, it's Charles Nemog wrote a sort of a just intonation library. So at the minute, I was kind of deep diving into sort of see how that was sort of what the features are in that, what and sort of ways of implementing them. And the first thing I sort of thought of was, what if I wanted to apply sort of just intonation or wacky tunings to a piece that I've already written? So I just kind of quickly downloaded a Bach MIDI file. So let me know if you can hear this. So, you know, like any good piece, it always any good project, you start with Bach and work your way. So I wish I'd been better keeping some notes here, but just from kind of Wikipedia, I sort of Googled, or I just checked out different tuning systems, and took I think just from the built-in Wikipedia page, and wrote a function to convert uh, uh, use this function that he has, that takes a ratio and a fundamental, and then gives us builds up a just intonation scale for us. And I thought, let's apply that and sort of see how that works. So I think we've got. So it works quite well for if you've got the 12. If you're literally just adjusting each pitch, you get some interesting results whenever you kind of play about with different tunings, because the way I've written the code is it'll only change the notes that it can. So we end up getting sounds like a strange minimalist piece, but it's quite an there's a lot of kind of interesting things going on. Just you can see maybe trying to kind of unpack sort of what's going on in here. It's been a while since I've looked at this, but I think I was using sort of running sort of two programs simultaneously. So the first one is mapping the original pitches onto kind of a set, kind of an expanded kind of set theory type of thing. So to try and include the octave. So, you know, just I can't remember what this little function I wrote was, but just took it to try and just work out what give the pitch a set number, but that goes beyond the octave. So it's not stopping at 12, going all the way. So I can get so when I convert it back, I can then use that information to map it onto into the where that pitch is in the octave, and in here using the ratio to MIDI sense to build a list and then position match those onto the original scale and then extrapolate out from that. It's been a while since I've looked at this, so I can't really remember. I didn't look over my code too much, but this is kind of I'm hoping to kind of get a chat with Charles to kind of go through the library and really kind of deep dive and kind of what's happening and unpack a lot of sort of interesting functions and functionality. And I think for that, I'll try and dig this out and really go back over my my messy patch and see what's actually going on and probably rewrite some of this. So anyone have any questions or want to ask why?
Just if you would be willing to share the links to the library that we
yes, in the YouTube channel, I'll put this patch and a link to the Charles's the OMJI library and all that fun stuff. I think it's listed in the OM libraries. That in that page, I think it's still a part of this. Maybe sorry, my computer is gonna not like me streaming and looking at the internet at the same time. Yeah, I think that we scroll through, we've got here the OMJI, and I'm hoping to look at the OMI all interval series library. I think that's going to be interesting. So I'm not going to take. I think we're kind of now at the sort of 7:30 my time anyway. So thanks everyone for sharing. Thanks James for giving us a run through your two patches, and Karim for giving us a sort of a look and glimpse into what's happening and to some of the hidden functionality in OM. And Nigel, hopefully next time you'll get your patches sorted and you can show us the.
I'll figure out where stuff is hidden eventually.
That's great. Thanks very much, everyone. It's been really great, and thanks for joining us there.